Hi, I'm Andy and this is question 2 on the AQA Core 4 paper from June 2016. For more questions on this paper, click the eye in the top right corner. In question 2, it says by forming and solving a suitable quadratic equation, we need to find the solutions to 3 cos 2 theta minus 5 cos theta plus 2 equals 0 in the interval 0 to 360 degrees, giving your answer to the nearest 0.1 degrees. Before we start this question, first notice the region is not inclusive of 0 and 360. In this problem we've got cos 2 theta, and if we want to be able to solve it we need the whole thing in terms of cos theta. So we're going to use the identity for cos 2 theta that expresses it in terms of cos squared. So the identity that we need to know is that cos 2 theta is equal to 2 cos squared theta minus 1. Now you can derive that quite easily from the addition rule in the formula book. I'm not going to do it here, but some questions often ask you to do that, so make sure you can do it. But I would recommend for the purposes of the exam that you memorise these. So we can say now that 3 multiplied by 2 cos squared theta minus 1 in a bracket minus 5 cos theta plus 2 equals 0. Expanding out the brackets and simplifying, here we get 6 cos squared theta. We'll have a minus 3 here, we'll deal with that later. We're going to have minus 5 cos theta. And here we've got 3 times minus 1 is negative 3, plus 2 gives us negative 1. From here you could use the quadratic formula, but it'll factorise quite nicely. I'm going to use a modified version of the AC method, which says I need two numbers that times together to make AC, so 6 times negative 1 is minus 6, and two numbers that add together to make B, which is negative 5. In this case, minus 6 and plus 1 will do the trick. So in a pair of brackets, I'm going to put 6 cos theta minus 6 and 6 cos theta plus 1. Now because I multiplied C by 6, this answer will be 6 times 2 large, so I need to take a factor of 6 out of here, and I can do that from the first bracket and make this cos theta minus 1 and 6 cos theta plus 1. So this gives me two solutions. It tells me that cos theta could be 1, and it also tells me 6 cos theta could be 1, and if you rearrange that you would get cos theta equals negative a sixth. Now if I solve cos theta equals 1, thinking about the graph, that would give me 0 and 360. But remember, they won't be valid solutions to the problem because the region is 0 to 360, not including the endpoints. We'll solve the other one. First of all, make sure your calculator is in degrees, which it is, and we need to do inverse cos of negative 1/6. And that gives me 99.6 if I round to 3 significant figures. And to get a second solution, I need to do 360 minus my answer. Make sure you use the exact value up here, and that gives me 260.4. So my final answer for theta is that it will be the two solutions that are within the region here, 99.6 degrees and 260.4 degrees.